Greetings and salutations. Here's the video for 2.4. Okay, similarity and transformations. Remember, similarity, two figures that are basically the exact same shape. One is probably larger or smaller than the other. That's similarity. And if you look at what we have here, notice the transformations that were done to this triangle. Okay, so we started here and we translated. Then we reflected, then we dilated. And if you remember in geometry, a dilation can make things bigger or smaller, which drives me nuts, by the way, but it's all good. I wasn't that sane to start out with. Okay, let's look at a model problem. The point 410 is the vertex of a triangle. Vertex, where two sides meet, two lines meet. Okay. The triangle is reflected about the y-axis, meaning the x-coordinate changes its sign. So now it's negative 410. Dilated by a scale factor of 2 with the origin as the center of dilation, and then translated up 5. Okay, so over the y-axis, so the x changes its sign. So now it's negative 410. Dilated by a factor of 2, multiply each of those by 2. Negative 820, and then it is scaled, translated up by 5. So it's negative 820 plus 5 is 25. So our final answer, Regis, old joke, beach ball of death, is negative 825. Okay, that's where it lands, and we're going to do a bunch of those. All right, ready for the next page? Okay, a transformation changes the size of a figure but maintains its shape. This transformation, okay, now if you remember, rigid motions don't change size, so it cannot be a rigid motion. What changes size? A dilation. Yes, yes, yes. So it could be a rigid motion, transformation, or dilation. Nope, not a rigid motion. It can't be a rigid motion, transformation, or dilation. What they talking about, Willis? Obviously here, I'm hoping it's obvious. If it's not, don't sweat it. Choice B is the correct answer. It is a dilation. A dilation changes size. Everything else is a rigid motion because it does not change size. All right, let's look at this. The point, 10, negative 9, is the vertex of a figure. The figure is reflected across the y-axis. All right, so we're starting at 10, negative 9. I have the beach ball of death. Okay. Okay, then the figure is reflected across the y-axis. So what changes its sign? Okay, do we all agree that the x changes its sign? It's going to be negative 10, comma, negative 9. Does that make sense? Pause if you need to, write down a question. Okay, it was dilated by a factor of 5 and then translated negative 5 units vertically. So it was scaled by a factor of 5. Hold that thought. So now we're going to multiply each of those coordinates by 5. Okay, negative 10 times 5, negative 50. Negative 9 times 5, negative 45. Okay, that's where we ended up now. Now it's going negative 5 units vertically up and down. So it's going 5 units down. So we're going to basically subtract 5 from 45. That making sense? I hope. And a negative 45 minus 5 is a negative 50. So we have, it's going to be at negative 50, negative 50. Those are not good odds, are they? Okay. And when you're adding sign numbers, I'm apologizing in advance. Same sign, add and keep, different sign, subtract. Take the sign of the larger number, then you'll be exact. Okay, enough torture? Okay, let's look at the next one. Here we go. The point, -4, -6, is the vertex of a figure. Doesn't even really matter what figure it is. The figure is translated -3 units horizontally, rotated 90 degrees counterclockwise, dilated by a scale factor of 5. Where are we going to end up? Let's see. Okay, so we translate -3 units horizontally, which basically means subtract 3 from the x-coordinate. That puts us at -7, -6. We all good with that? Now we're going to rotate 90 degrees counterclockwise, which makes us do -y comma x. So the thing over here that's in the y position is going to move to the front and change its sign, and the -7 is going to slide on back. So now we have 6, -7. Then we're going to dilate by a factor of 5, which means multiply each of them by 5. 6 times 5 is 30. -7 times 5 is 35. That's where we end up. That's our final point. Okay, everybody good? Again, pause if you need to. Okay, I'm going to leave you to do this one by yourselves. Okay, so pause the video, please. Do it and see how you do with it. And then if you need, come and ask me, write down questions, concerns. All right, let's take a look at this one, number 13. The point, -1, -8, is the vertex of a figure. It's reflected across the x-axis. The y changes its sign. Rotated 90 degrees counterclockwise. Dilated by a scale factor of 2. Then translated 7 units horizontally, 7 units vertically. And then it did the hokey pokey and it turned itself around, because that's what it's all about. Okay, so let's do it. Okay, so we're going to finish this one, but first let's look at it. So, -1, -8 reflects across the x-axis, so the y changes its sign. Then we rotate 90 degrees. We have -y comma x. We dilate by 2. We have -16 comma -2. Okay, sorry about that. Okay, so we dilated by 2, so we multiplied each one by 2. Now we're going to translate -7 horizontally. So what is 16 minus, -16 minus 7? Okay, why isn't it typing? Hello, Mr. McPewter. There it is. Okay, -16 and -7, I believe is -23. Feel free to check me on your calculator. And then we're going to 7 units vertically, so we're going up 7. Okay, so we're combining a +7 and a -2, 7 minus 2. So our final resting place is -23.5. Okay, I will be back with another video very soon. Stay tuned. After these messages, we'll be right back.